Hello, everyone. Good morning, good afternoon, or good evening, depending on what time you're watching this video. This is me, Teacher Kent, and today we're gonna talk about a new topic. Well, it's not really a new topic, but more on a continuation of our previous topic. I remember I had a video about electrical circuits. And last time, we talked about electricity or how electricity was discovered, not created because humans did not create electricity. Electricity was here before humans were, and we merely discovered how to use electricity. Today, it's time we find out how we use electricity for our appliances or the things that we use at home. Are you ready? Let's start. How appliances work. Now, appliances and electricity. I will be talking about four different things today. First is that the basic electrical circuit. Second, the heating appliances. Third, the motor appliances. Fourth, the combination appliances. Basic electrical circuits, we're gonna be reviewing it just a little bit. Don't worry if you forgot it. We will talk about it during our online class. Okay? Next, heating appliances. These are appliances that give out heat. And how does electricity give out heat? Third, motor appliances or appliances that provide motion or movement. How does electricity make you move? Finally, we have the combination appliances or the combination of those two that I talked about previously. Are you ready? Let's start. Basic electric circuits. All appliances make use of electric circuit. That's why it's important for you to understand this because when you go to Matayom or when you go to university, if you chose a job or a course that needs knowledge in electrical circuit, at least you know what is the basic electrical circuit because every single thing that we have in the world came from the basic electric circuits. The way they use it depends on the function of the appliance. And do you still remember the basic electric circuit? Don't worry, I got you covered. Electrical circuit. There are, if you remember, four parts of the electric circuit. We got, let me just, there you go. The first part, this black and this red part. Now, the resistor, we don't have that. We can just erase that. Let Don't pay any mind to that yet because that's not in our book. You will find out more about those when you go to Matayom. Anyway, let's continue. These two parts are called a wire. Do you remember the wire? The wire acts as the place or the highway for electricity to move. We also got this one, the switch. The switch allows us to control whether we want the electricity to move or not to move. After that, we have these. These are called the battery. And the batteries, they are where the electricity comes from. Okay? Positives and negatives. Finally, we got the light bulb, or what the electricity is used for. In this experiment, or in this illustration, we use electricity to light up a light bulb. Let's go to the next topic. Don't worry, we will go in depth next time we have a class. I already know that you know a lot of it because we already had it at school, but I want you to remember it because we don't have classes. So the best way for you to retain knowledge is for me, the teacher, to repeat it. I know it's a bit boring. That's why I try to find other topics that will make you be more interested. Next, please. The first part, the first appliances we're going to talk about is the heating appliances. Heating appliances convert electrical energy into heat, which is used to toast bread, warm coffee, dry the hair, or perform other helpful tasks. This heat is developed by passing current through a special wire called an element. Since the element makes it difficult for electricity to pass through it, some of its energy turns into heat. Okay, let's go to the next one. The electricity uses so much of its energy to overcome the resistance of a toaster element, for instance, that it glows bright red, thus toasting the bread. Common heating appliances include toasters, toaster ovens, coffee makers, clothing irons, deep fryers, slow cookers, popcorn poppers, and many more. Now, we are talking about heating appliances. Appliances that need heat. For example, your electric cooker or your rice cooker, it needs heat. So we use electricity to have heat. And how do we do that? By using this. This diagram, the nichrome coil is called the element. Okay, just let me write it. It's called the element, okay? Instead of the light bulb, we use the element or the nichrome coil. So it works almost the same as the basic electrical circuit. There is a wire, there is a battery, there is a switch, and then instead of the light bulb, we have the elements. The energy from the battery goes here to the element. The switch allows us to turn off or to turn on the appliance. And the wire allows electricity to move through it. Okay? Now, the nichrome coil is a special type of element. The elements will allow electricity to pass, but before they pass, it will have a hard time before it can move. It will allow it to move, yes, but it will take up a hard time. It will need a long time before it can move to the other place. So what will happen? I said before that electricity is not lost. It's just changed from one form to the other. So what happens here is that from electric form, it will become a heat form. It will become hot. It will lose some of its electrical current because it will become hot. And you will know that it is losing its electrical current because the element will turn bright red. And red means the color of hotness. Okay? Now, you will ask me, teacher, why are we going to use this? Why are we making something hot? It's already very hot in Thailand. Yes, you're correct. But we have a lot of appliances that we use heating for. For example, we got the electric iron, the electrical heater, and the electrical kettle. The hair dryer is a heating appliance, but this is a combination appliance. We primarily use the electrical iron and the electric kettle here in Thailand. We don't need the electric heater because Thailand is already very hot. The electrical iron is needed to make your clothes look clean, look fresh, look flat, look presentable. Okay? Your mother uses it to clean or to make your dresses or your shirts look better. We need the electric kettle to heat up water. We need a lot of things that we need to use for water. We need hot water for soup. We need hot water for noodles. We need hot water for coffee. That's just some of the things we need that is helped by heating appliances. Now, let's go to the next type of appliance, the motor appliances. Motor appliances convert electrical energy into movement. This power cuts and blends food, open cans, grinds waste, picks up dirt, and moves air. A motor converts electrical energy into magnetic energy that rotates a shaft. The end of this shaft may have a blade or other attachment that does the actual work. Motor appliances include food mixers and blenders, electric can openers, garbage disposers, vacuum cleaners, ice cream makers, electric knives, electric clocks, fans, humidifiers, and electrical shades. This is the diagram of what is an electrical motor. Here is the fuse. Here is the switch. Here is the wire. We got the AC or the battery, the electrical current, and we got the motor. Now, let's just disregard the fuse. Some appliances has a fuse, some don't. It's the same thing. From the electrical energy, it will travel to the wire. It will hit the motor. The motor is actually an area that has a lot of magnets that will allow the metal parts to move around. It uses the magnet so that it can move apart using electricity. Remember electromagnetism? Yes. And we also got the switch where you can turn on or off the item that you need. Let's go. Now, what type of appliances do we need that needs motion? We have a lot. Well, first and foremost, the thing that Thailand should always have is the fan because Thailand is very hot. We need the fan for the air to move around better. We also need it for vacuum cleaners. It will move around inside it, the motor moves it, and the motor will suck the air. That's why we need it for vacuum cleaners. We also need it for the air cons and the things that we need. The air cons need this part, the fan, to move around, then they make cold air. We also need the motor appliances here in our washing machines. If you put your clothes there, you will notice that the clothes will move. That is because there is a motor in the washing machine that will make the hollow area move around, which will then help wash our clothes. Aside from that, we also need the motors for our cars. and our motorcycles. They will help move the motor inside it, and then in the engine, it will then move your what do we call your tires, which will allow for us to ride a car or a motorcycle. Next, let's go to the final part, the combination appliances. Some small appliances need both heat and movement. The most popular is the electric bread maker. It mixes doughs, then bakes it into bread. Other combination appliances include hair dryers and stirring popcorn poppers. Some appliances, like I said before, need both heat and movement. First example, the bread maker. If you've actually seen how bread is made, we have what we call the mixer. It looks like it looks like it has a metal claw, but it turns around in a circle. They need it to need bread or dough. And we also need them for the hair dryers. We need both the hair, the heat, and the movement. First, we have here the fan, which is moving, which is moved because of the electricity. And we also need this part, the hot air, because the air dryer will give out warm air so that the hair, the wet hair that you have, will be dried. That's why it's called a hair dryer. So, this little invention is a perfect example of a combination appliance in which they need both heat and motion. Now, let's just review, okay? Appliances are classified into three types. First, we got the heating appliance, where we need to make stuff hot. Second, we got the movement appliance, in which we need an object to move. And third, we need the combination appliance, in which we need both hot and movement for it to do its job. I will see you again on Friday, and we will talk about or take a review on electrical circuits. After electrical circuits, we can finally move on to our next topic. I will see you later. Bye.